everyone. How's everybody doing? Getting late in the day. It's dark in here, so makes it easy to relax. Thanks for having me. Really excited to be here. It's been a great conference so far. I'm Landon. I'm CEO and one of the co-founders of Peak Energy. If you haven't heard of us, we're a sodium-ion battery startup. About 2 years old now. We're focused on grid-scale energy storage. It's not my first rodeo in a battery company. I've been doing batteries most of my career, so is most of the company. Started out, was first exposed to this at Tesla when I joined in 2012, right at the beginning of the Model S ramp. Was there for about 5 years, all the way through Model 3, and did a variety of roles there, but ended my career, the last about half of my time there was in battery manufacturing or on the pack side. And then I went to Northvolt in Sweden, joined there when we were around 20 people as chief automation officer, helped scale the company up on our first pilot line and then our first 8 gigawatt hour of production in Skellefteå, and then led our North American expansion. So I've seen kind of multiple stories of scaling really hard things. EVs are really hard to do. I think when we were doing it at Tesla, was pretty much countless, almost every time, especially in the beginning, we would talk to anybody. There was always a perspective that it was impossible to build a new car company, right? It was not possible. We heard a lot of the same thing at Northvolt, and obviously very different outcomes between the two companies. And so what we've done is, as we come in and are taking another shot at this with Peak, is to try to learn from those experiences, take the best from what we saw work and try to correct the things that didn't. So I want to talk a little bit about first, the importance of what we're doing here in terms of battery industry and why we need to do that, make a case for that. And then talk a little bit about why we think we'll be successful this time, what we're doing differently, and hopefully offer a little bit of a blueprint for others to follow too. Because personally, I feel super passionate about building this industry in the US. I think it's a strategically important thing, economically, militarily, almost in every possible aspect. Skip over a couple things here. I think I'm preaching to the choir here, given the other presentations, but batteries are an absolutely essential component for any advanced economy. The US cannot not participate in this industry in a meaningful way and still expect to remain a global power in 50 years. I would rank these up there in importance with semiconductors and AI and any other foundational technology you can think of for the 21st century. If you think about the number of things that batteries are inside of, and then think about how much those batteries cost and represent a portion of the BOM cost of those things, be it a car, be it a phone or a computer, it's a material component that, if you can't make it, that's going to mean you can't do those things. And if you can't make it cheaply, that means your industries that depend on that component are not going to be competitive. So we've got to get in this fight. Zeroing in specifically on grid storage, which is where we're starting out. Our first product is a 3.5 megawatt hour, 4-hour system, grid storage system. Batteries, if you're not familiar with energy storage systems or battery energy storage systems, are already a massive industry. The US is just behind China in terms of deploying these onto the grid. And it's not an industry that is entirely driven by subsidy. Most people think that California is probably the place this is happening, and it is a massive market, but it's actually happening fastest in Texas. And Texas is definitely not subsidizing this more than anybody else. It's happening there because it's economically the best, most efficient solution. And it's simply because of what we've heard many times, on the panel just before this, is solar and wind are intermittent, but that's not really a new thing. Like the US energy grid, in terms of reserve capacity, has 30% of its capacity that's just not used. And what batteries help you do is just move those peaks and valleys around. And in fact, if you think about the data center challenge that we're facing, and it's a massive challenge, it's huge no matter whether this is a bubble or it's not a bubble, it's a big thing. There was a recent study published by Duke University that said if you put a 2-hour energy storage system at every data center that's going on the grid, and 2 hours is what's getting deployed. So this isn't new technology. This is what's being deployed right now economically efficiently. You could add an additional 80 gigawatt hour of equivalent data center capacity. Now, just for comparison, there's about 30 gigawatt hour of total data center capacity today in the US, and we think we need to add another 30 over the next 10 years in most scenarios. So this is, just by doing that, you sort of solve this problem with some margin. So it's an incredibly important industry, an incredibly important technology. And right now, it's entirely dominated by China, not just at the battery level, but in just about 5 years, they've gone from almost non-existent in terms of energy storage systems installed on the grid to well over 50% of the market of systems installed out there are Chinese systems. These are being installed on the grid. They run Chinese software. They have Chinese PCBAs. If you think, if you believe that the concerns we had around Huawei are valid, this should also concern you. So this is something that we really got to get into the game on. Okay. And the other major reason, other than the fact that just batteries are important, they're in everything, is that they're getting they're getting better every year. They're getting better really, really quickly. And they're already good enough. I mean, if you look, Goldman Sachs put a report out last year that said that they forecasted that by 2026 or 2027, EVs would be cost competitive with combustion engine vehicles. And that was at an $80 per kilowatt hour price. Well, end of last year, the global average price was under $80, $78 per kilowatt hour, according to Bloomberg. In China, the price is well under $60. It's probably in the mid-50s, might be even in the 40s, depending on the battery that you're looking at. In China, they're already there, and it's going to happen. Cars take a little bit of time to get it in there, so I think Goldman's pretty right on thinking that around 26, 27, you're going to be cost competitive. Right? So we can't ignore this. It's not a political issue. It's not like this technology is getting better. It's getting better for everything that's inside of, and if we don't get in this game, we're going to be left out of the next century. Anyway, I think I can not belabor this point, but China completely owns this industry. It doesn't just own it at cells or systems, it owns it at all the component levels on lithium ion. This is a pretty discouraging graph if you know how hard each of these component areas are and how much infrastructure has gone in to the industry. I think last report was China's capacity was about 4 times their domestic demand. So they're able to supply the entire world right now with batteries without anybody else. If we all turned off the factories, they could supply everybody. So we got a lot of room to catch up. And they are not just leading in terms of bringing this technology to market. They are generating obviously pretty massive cash flow from this industry, and they are pushing that cash flow into R&D. I mean, this graph would have been completely different just a few years ago, and in the amount of time that they managed to dominate not just the manufacturing but also the research should really concern us, because we're not going to, design or R&D our way out of this problem. We have to do both. We have to lead both on innovation. We have to actually get in the game on manufacturing. Okay, so how do we do this? It's easy to get discouraged. The challenge is pretty huge. And like I said, I've seen this a couple times before. I've seen it successfully done in a really hard way at Tesla. I've seen it not so successfully done firsthand at Norfolk. The things that we learned and the way we're trying to do it differently right now is really build a strategy that really does sort of 3 things at its core. The first is you try to focus on a technology that doesn't compete so head-to-head with where the incumbents have massive scale advantage. LFP, which is the technology, the battery technology that's trying to sort of build their entire industry upon, is gaining market share everywhere because it's a great battery technology. It's very cost-effective. It's good enough for most applications, including EVs. And it's one that there's a lot of work and investment going on here. I'm not saying we shouldn't do those things at all, but competing head-to-head with China on that, where they have probably $500 billion of capital already put in the ground around these supply chains, is a pretty tough brute force approach to attacking this. So what we are trying to do is pick a technology that is next generation, that is already scaling, that isn't just an idea in a lab, but is actually out there scaling up. In fact, our technology, sodium ion, scaling up in China. So you can sort of look at them as an example, a validator of the technology. But it's similar enough to lithium ion where you can leverage a lot of the same expertise and supply chain, but it's different enough that those incumbent advantages are not insurmountable. So that's the first thing, like look for a next generation technology that is different enough, but not too different that you can get in the game. The second thing is to vertically integrate, but do it stepwise, right? It's not enough, like we don't really help ourselves if we just do systems here or just do cells here or just do a component and then we're cut off down the road or we can't buy efficiently. We got to do the entire supply chain. But if you try to do it all at once, especially inside of a single firm or a small groups of firms, you're going to need either a lot of capital, a lot of very, very patient capital, or you're going to fail. And that's one of the things we learned at Norfolk, right? We tried to go all the way back to, we had a joint venture with Galp for lithium refining. Then we did precursor manufacturing and recycling. We were doing all these things, right? And it kind of, you have to, right? If you want to bring the whole thing in, but the challenge that we saw, and we didn't realize this until too late, is that like you should do that in a stepwise fashion. Because if you have these cross dependencies in these upstream supply chains and you can't depend on them, it just layers risk upon risk in your industrialization strategy. So you need to, and that's why the first one's important. If it's too different, if there's like no supply chain for the new technology that you're trying to bring online, you can't really vertically integrate in a sort of controlled fashion. And the final thing is really try to leverage wherever you possibly can technology transfer. And that's especially important in manufacturing. I think when people think about this and they think about technology transfer and they haven't really been in a scaled, especially battery manufacturing context, people think about patents or chemistries. And those are important, of course, but the US is still really great at those things. We have a lot of that really good stuff. The stuff that we don't really have is capital equipment that's super, super efficient. And these industries, I mean, we saw the cost curves. It's super competitive. So if you're bringing in equipment that costs 3 times as much and doesn't do as well, or you don't know how to run those lines, or you don't have access to supply chain that scale, you're not going to be competitive without too much subsidy. Okay, so that's kind of our core idea, but it's not just us. I think this applies to sort of anybody who wants to go in and try to build a new battery company. Now, talking a little bit about what we chose, I mean, sodium ion is the technology that we're building our company on. I actually first learned about sodium ion a few years ago when I was at Norfolk. We made some investments in a sodium ion startup called Altris, and when I first learned about it, I'd been thinking about this LFP problem for a long time, and at Norfolk we looked at it, and honestly, we sort of decided not to go into it because we couldn't convince ourselves that we could overcome this scale advantage that especially China already had. But when we found sodium ion, it looked like it was potentially similar to LFP, but better in a lot of really important ways. Importantly, that's not just on cost, although the theoretical cost floor for sodium ion is below lithium ion, just because there's not really anything expensive in there. I'll go into that in a second. But from a performance perspective, it's got advantages in safety, it's got advantages in operating temperature ranges. That's very important for energy storage, by the way. And it's got a lot of supply chain benefits. The only one place where it's really behind is energy density. But if you look at the history of all battery chemistries, and this is definitely the case with LFP as well, energy density is the thing that you can kind of depend on to increase. And there's multiple pathways that are well trodden because they've been used successfully on LFP or other parallel chemistries that we see as super promising here. So this is getting better all the time. Okay, from a supply chain perspective, the US really should be the dominant player in this space. The primary precursor to most sodium ion cathodes is sodium carbonate, so soda ash, which is like the 10th most used inorganic material in the world. Number 1 on that list is water, just to give you an idea of how big these commodities are. Its analog in lithium architectures is like lithium carbonate. We have the world's largest natural reserves of that. Those are in Wyoming. It's something like 92% of the world's proven natural reserves. But importantly, this is actually not really a constrained resource either. There's a lot of countries that synthetically make this material. So just in terms of like energy security and not having too much material scarcity, I think it's a super good thing for the technology to not only be able to come out of the ground in one place. Doesn't matter where that place is. I think it's good for everybody if they can make this. Now, we should lead this. We don't. China currently dominates it. If you want to buy battery cells, like large-scale sodium-ion battery cells, today, the only place you can get them is China. And they're building these really quickly. So they don't have a scale advantage yet, but they have a head start on us. And if we don't get in this game right now, we're going to lose. We're going to lose the next leg of this race, at least on the lower cost side of the equation. Okay, to the vertical integration point, the strategy we have adopted here is sort of a 3-phase plan. Phase 1, you really need an end customer to prove the demand for this technology. finance a factory, get offtake. So we've started focused on systems. That's what we're doing now. We're building those systems in California. The entire system is our design. We just import the cell. About half the company's ex-Tesla Megapack or car pack engineers. We've got some really exciting stuff. First system's going to go on the grid at the end of this year. Very excited to announce that stuff just in a few months. That's phase one. Phase two is building cells. And to get from phase one to phase two as fast as possible, and I think everybody knows this, but the most important thing about doing any of these plays is speed. You need to go sequentially as fast as you possibly can, step to step. And the best way to do that is to basically make the same cell you're buying in phase one in phase two. So that goes to the technology transfer. Work with partners who are willing to share that and help you manufacture in phase two. But we don't want to just be a contract manufacturer, only have part of the supply chain. We need to industrialize, bring that whole thing here. And so that's why we have a phase three. Already we're working on R&D for a next generation cells that are even slightly more different than current generation sodium ion, give us a little bit more of a reset of the scale advantage there. And when those are ready, probably around 2030, we'll cut those in along with bringing in additional supply chain components. So that's kind of how we do it. We're doing all of this as fast as we can, and it's only 5 years, really, to get to that point, which isn't really much slower than if you're trying to do all this stuff in parallel. But it substantially de-risks because you kind of prove that you can do each step as you go. Okay, just rounding us out, that's kind of the strategy, that's our play. I'd love to share more about sodium, but that's not kind of why I'm here. I wanted to more make a case for how you play this out. So just to end this, I think there's some policy measures that would be really helpful to kind of maximize the potential for strategies like ours to work. The first is that it's a fact, you can't make a business case for battery factory in the US work right now without the production tax credits and the investment tax credits, at least for energy storage systems that are in the IRA. Those can, I think they could benefit from some tweaks, especially the investment tax credit. Right now, there's no real restrictions in that thing about the deal with vulnerabilities from a national security perspective. So there's definitely ways you can improve that and save some money. But at the end of the day, those policy measures or something like them need to be in place to make the business case work. The second thing is really encourage technology transfer. I think there's a potential to go too far in the wrong direction about trying to throw up trade barriers, say that anything working with any firm in China is verboten and can't do any of this stuff. That will basically make it impossible to do what's been kind of done to the US for the last 30 years, right? There's been a lot of tech transfer. Tech transfer is not necessarily a bad thing. It should go in both directions, and we're finally in a position where we can get some tech transfer back. So we should encourage that. We shouldn't restrict it. And the final thing is really, and this is something that I think has largely been missing from any sort of industrialization strategy in any policy that I'm aware of. It's done a lot in the R&D side of the house, but really encourage as much as you possibly can adoption of technology that isn't just the thing that is popular right now. Because I can guarantee you that, that our competitors, doesn't matter where they are in the world, if they're already established manufacturers leading in this industry, they are not thinking every day about how do they build more LFP. They're thinking about the next generation products that they're going to put out in the market. And that means that and that's not 10 years from now. That's 3 years on those timelines. So we've got to be thinking about those now and less myopically focused on technologies that are in front of us and right in our face. So that's sort of the ask. But I really appreciate the time. It's been a great conference. It's been great meeting everybody. Hopefully this has been helpful, and maybe it'll inspire somebody to go build another next generation battery company so we're not so lonely up here. Thanks.